question tells us that Tarzan starts at 37 degrees to the vertical, which is this point, and we're trying to find his velocity at the bottom of his swing, and the swing is drawn by the green part. We're going to define that bottom part as h equals 0. So for this question, we want to figure out his initial height. So it's height over here. And we can do this by figuring out this distance, which is 30 meters times cosine 37, or 23.96. And now we want to figure out this part, which is 30 minus 23.96, or 6.04. So that means his initial height is 6.04. So for this question, we're going to use conservation of energy, which means that his total energy in the beginning will be the same as his total energy at the end. So we have his kinetic energy, his initial kinetic energy plus his initial potential energy equals his final kinetic energy plus his final potential energy. And for the final potential energy, we know that h equals 0, so this just cancels out. And we can also divide everything by mass, so that all cancels out. So now we want to solve for the final velocity in terms of all the other variables, and we get that it's the square root of initial velocity squared plus 2 times gravity times the initial height. So plugging in the values that we know, the question tells us that the initial velocity is 0 meters per second, and we solved that the initial height is 6.04 meters. So plugging that in, we get 10.88 meters per second. So that's the answer for part A. Now for part B, it tells us that the initial velocity is 4 meters per second. So we can still use that same equation we got for the final velocity, but this time we plug in 4 meters per second for the initial velocity squared, and the height is still the same, 6.04 meters. And this gives us 11.59 meters per second. So that's the answer for part